Have you ever wondered if the universe we live in is infinite? A question that has puzzled scientists, philosophers, and thinkers for centuries. This is the essence of the infinite universe theory. But what does it mean, exactly? In the simplest of terms, if the universe is indeed infinite, it implies that it contains infinite matter and energy. Now, that's a concept that is hard to grasp, but let's try to break it down. If matter and energy are infinite, then it means that every possible arrangement of particles in the universe must occur not just once, but an infinite number of times. That's where it gets a little unsettling, because if every possible arrangement of particles exists infinitely, then somewhere out there could be unlimited versions of you, living out every conceivable reality. Every choice you've ever made, every path you've ever taken, played out in infinite detail. Imagine infinite versions of yourself living out every possible reality. Or could our universe be just one among many in a multiverse? The multiverse theory isn't a concept pulled from the pages of science fiction novels, but a serious proposition within the scientific community. The theory suggests that there might exist an infinite number of universes, each with its own unique set of physical laws and properties. Just imagine countless universes, each a separate bubble in the cosmic foam of existence. Now let's take a step further into the eerie. There might be universes where the laws of physics as we understand them simply don't apply. Universes where gravity repels rather than attracts, where time runs backwards, or where life as we know it is an impossibility. Consider this. There might be universes that are mirror images of our own, where every decision you didn't make in this life, you made in another. Universes where history took a different turn, where civilizations rose and fell in ways we can't even begin to comprehend. But what's truly unsettling about the multiverse theory is not its vastness or the unfamiliarity of these potential worlds. It's the implication that in this infinite cosmic lottery, there might just be universes where your worst fears, your darkest nightmares, are the reality. Universes where the creatures that lurk in the shadows are not figments of imagination, but living, breathing entities. Now consider a universe where your worst nightmares are reality. What if everything you know is just a sophisticated simulation? An unsettling question, isn't it? This is the crux of the simulation theory, a concept that has both baffled and intrigued philosophers, scientists, and tech enthusiasts alike. The simulation theory proposes a chilling possibility that our reality, everything we've ever known, could be a computer-generated simulation. It's like living in a video game where the trees, the buildings, even the people around you are merely bits of data in a colossal supercomputer. This theory is not without its merits. As our computational power grows exponentially, we're creating increasingly realistic virtual realities. Some argue that, given enough time and technological advancement, we could simulate an entire universe. If that's possible, who's to say it hasn't already happened? That we're not the ones living in that simulated universe? The implications of this theory are profound. If our reality is a simulation, then what about our experiences, our emotions, our dreams? Are they real? Or are they just lines of code, programmed responses in a grand simulation? And if we are in a simulation, who's running it? Is it some advanced alien civilization conducting an experiment on a cosmic scale? Or is it a future version of humanity looking back at their past? These questions are as fascinating as they are unsettling. But they force us to confront our understanding of reality and question the very nature of our existence. Are we all just characters in an advanced AI's video game? Could our universe be in a false state of existence? This mind-bending question brings us to the false vacuum theory. Imagine a ball sitting in a valley. It's stable, but not in the lowest possible valley. That's what the false vacuum theory suggests about our universe. It's stable, but not at the most stable state it could be. We're sitting in a false vacuum, an unstable state that could at any moment transition into a true vacuum, the lowest energy state. But why should this worry us? Well, if our universe were to transition into this true vacuum, it wouldn't be a slow, gradual change. It would be more like a bubble of true vacuum forming and expanding at the speed of light, swallowing everything in its path. The laws of physics inside this bubble could be entirely different from what we know. Every star, galaxy, and planet, every bit of life as we know it, could cease to exist in an instant. The universe as we understand it would end, replaced by a new one with unknown properties. It's a chilling thought, isn't it? Now, before you lose sleep, remember that this is just a theory. It's a possibility, not a certainty. And even if it were to happen, it would occur so fast that we wouldn't even know what hit us. We could be living on borrowed time, waiting for the universe to reset. Ever ponder why we haven't found extraterrestrial life? This question is at the heart of the Fermi paradox, named after physicist Enrico Fermi. It's a conundrum that has puzzled scientists for decades, and it's as mystifying as it is frightening. Let's dive in. The universe is unimaginably immense. Imagine billions upon billions of galaxies, each one teeming with millions of stars. Around these stars, there could be numerous planets, much like our own. With this sheer number of celestial bodies, the probability of life existing elsewhere seems almost inevitable. But here's the paradox. If there are so many potential homes for life, why haven't we detected any signs of it? Why is it that our sophisticated telescopes and satellites have come up empty, with no evidence of extraterrestrial civilizations? This is the question that Fermi famously posed, and it remains unanswered to this day. Some scientists propose a chilling explanation. Advanced civilizations might be inherently self-destructive. Consider our own history. As our technology has advanced, so too has our capacity for destruction. Nuclear weapons, environmental degradation, artificial intelligence gone rogue. These are all existential threats that we've created for ourselves. So, could it be that other civilizations have followed a similar trajectory? Could they have developed technology so powerful and so dangerous that it led to their own downfall? This is a sobering thought. It suggests that the silence of the universe might be the result of countless civilizations extinguishing themselves in a blaze of technological glory. But it's just a theory, one of many attempts to solve the Fermi paradox. Nevertheless, it serves as a stark reminder of the potential dangers of unchecked technological advancement. It underscores the need for us to tread carefully as we continue to push the boundaries of our knowledge and capabilities. Could we be following the same path towards self-destruction? It's a question worth pondering as we gaze up at the stars and into the silent void of space. What if the universe is destined for a slow, cold death? This rather chilling question introduces the concept of the heat death of the universe, a theory that suggests a rather bleak future for all existence as we know it. Imagine a universe that has used up all its energy. Yes, every last bit of it. This scenario is what scientists refer to as heat death. The term may sound fiery, but ironically, it's quite the opposite. Heat death doesn't imply a universe engulfed in flames, but rather one that has cooled to such an extent that it can no longer sustain any form of life or activity. According to the second law of thermodynamics, energy constantly moves from areas of high concentration to areas of low concentration until a state of equilibrium is achieved. In the context of the universe, this means that eventually all energy will be evenly distributed and no more work can be done. This state is known as maximum entropy. The chilling implication of this theory is that once the universe reaches this state of maximum entropy, all life and activity will cease. Stars will burn out, galaxies will drift apart, and even the smallest atomic movements will stop. This scenario is billions upon billions of years in the future, but it's a sobering reminder of the transient nature of everything, even the universe itself. In the end, the universe might simply fade away into nothingness. These theories might be frightening, but they also prove how fascinating our universe is. From the concept of an infinite universe, stretching beyond what we can perceive, to the thought-provoking multiverse theory suggesting countless alternate realities exist alongside our own. Then there's the simulation theory, which proposes that our reality might be nothing more than a hyper-advanced computer program. And let's not forget the false vacuum theory, suggesting a catastrophic energy release could entirely reshape our universe. The Fermi paradox questions why, in a universe so vast, we've yet to encounter extraterrestrial life, and the chilling heat-death theory, predicting a universe devoid of energy, lifeless and cold. While these theories might send shivers down your spine, they also highlight the sheer vastness and unfathomable mystery of the universe. They remind us of our humble place within it. Remember, in the grand cosmic scheme, we are but a speck in the infinite canvas of the universe.